Hi, my name is Cameron Stanley. I am in 6th grade, and the title of my project is How Effective Are Bioswales? Last year, while I was at the Regional Science Fair at YSU, I was walking outside and balancing on a curb when all of a sudden I lost my balance and fell into a shallow pit. Since then, I've wondered what the pits were for because it was weird that they were right next to a road. After doing some research, I discovered that these pits are called bioswales, and they are roadside channels designed to minimize flooding and filter out pollutants by capturing water and filtering it through multiple layers of material, which can include dirt, rocks, and vegetation. I thought they were very interesting, so I wondered just how effective they are at capturing water and filtering pollutants. But to determine that, I did a lot of research. Once I had found out as much as I could, I came up with my hypothesis, which is that a well-designed bioswale is effective at capturing water and filtering out pollutants. My research made me realize that I would need to complete 2 sets of experiments to prove or disprove my hypothesis. One experiment would be creating the well-designed bioswale from my hypothesis, while the second would be implementing that design to see how effective it is. For my first set of experiments, I found that I would need to have 2 separate things. Different types of medium for my bioswale and debris to measure. For medium, I used 3 different sized rocks, a fine sand, and soil. For debris, I used yellow food coloring, Italian seasoning, and glitter. How to find out what made the best bioswale design would involve a lot of testing and retesting, which I'll talk more about later in this presentation. The second set of experiments would use the bioswale I determined was best and implementing it into as close of a real-world situation as I could to determine just how effective it could be. To do this, I would need to create a scaled-down model of a real road. I learned that I would need a few different types of road models for this experiment well. The first experiment needed to determine 2 things: how well the bioswale absorbed water and how well it filtered debris. Each type of medium was selected for these purposes. The 520 milliliter plastic container and 1 large container were used as a container to build the bioswale in and to capture water where it could be measured. The 3 different types of rocks were obviously not picked for water absorption. Instead, they were picked to see how they could assist in filtering debris. There was the question of which sized rock would work best. I thought that the smaller rocks would be better than the medium or larger ones due to the larger amount of surface area of a lot of smaller rocks versus larger ones. But I still used all 3 sizes just to be sure. Sand was selected because we have all built sandcastles at the beach, so we know how sand and water work together. This heterogeneous mixture got put to the test in my experiment. Soil was an obvious choice, and as it is the main medium used in planting crops and in construction. My debris needed to be very visual since there would be no real way I could measure how much was filtering other than doing it visually. So I used yellow food coloring in the water so I could see what shade of yellow it was after being poured in the bioswale. Glitter and Italian seasoning would also stand out in the bioswale if it was filtered or in the water if it was not. Miscellaneous other material involved an X-Acto knife, a 480 milliliter cup, lots of water, and a pen and paper to record my findings. The second set of experiments required the construction of a scale road model. Based on the size of our work area, I decided on a 1/24 scale road. The roads were made out of 2x3 sheets of project board. I learned after the second road was built and experimented on that I would need to make another one. 2 sheets of project board were used. Road features like curbs were made with strips of balsa wood that were hot glued to the road. Various size containers were used to capture water at different locations of the road model. Each container was at least able to hold 120 milliliters. The design for the bioswale from experiment 1 was recreated into 4 smaller 4-inch by 4-inch by 3-inch containers. A 120 milliliter beaker and lots of water were also used. Miscellaneous items included a hot glue gun, an X-Acto knife to cut out curves, and pen and paper to record results. The procedure from experiment 1 was pretty straightforward. I perforated the bottom of a plastic 520 milliliter container multiple times so that water could freely flow through it. Below it, I put another container to collect the water so it can be measured. From here, I simply added a different medium to the perforated container and recorded the results. It's important to mention that all containers were completely dried after each experiment. The rocks were also dried completely. Sand and soil were replaced with fresh ones after each experiment. This was done so as not to alter the results. The 3 different sized rocks were tested one at a time. Sand was next and didn't work as well as I thought it would, but I'll talk a bit about that later. Next was the soil, which had similar results as the sand. My last experiment was a combination of all the material later in the container. Each medium was tested 6 times and an average was taken. The procedure for experiment 2 started out straightforward but got a little more complicated when I realized that water will do what it wants to do instead of what you want it to do. A 124 road model was created. It was 6 inches and 5 feet long. Scaled up, this would be a 12 foot by 120 foot stretch of road. A 5-degree slope was used for all experiments. There was some trial and error before I discovered that anything less than that would result in the water not flowing like I wanted it to. For each of the 4 experiments involving the road model, I simply poured 120 milliliters of water at the top of the model and measured how much made it to the bottom container and how much made it into the containers I placed in different parts. The first experiment was the control. The second experiment added gutters, and it was my intention to add the bioswales to the second experiment, but I found that water does what it wants, and the second experiment did not succeed as I thought it would. So, I created another road model where I altered the curves to better direct the flow of water and used that model for my third experiment. I added the bioswales to that model for the fourth experiment. Again, each experiment was completed 6 times and an average was taken. After completing the first experiments, I found that small rocks were best at filtering out debris. I was correct that the increase in surface area would lead to more debris being trapped on the surface of the rocks. Soil also did well at filtering them out, as it was the only medium where there was an observable color change in the collection container. Soil was also best at absorbing water. This was after a thin layer of small rocks was added under it. I found that without the rocks, a good bit of the soil filtered through the perforation. Sand failed completely. Almost all of it ended up in the collection container along with the water. Adding a thin layer of rock to the top did not work like it did with soil, as, again, most of the sand was gone. For the road test experiments, the road model with gutters added failed completely. Water either ended up all in the collection container or all in the gutters. The road model with angled curves I created from this failure ended up working, and I was able to get consistent enough results with it to add bioswales and test it. A very interesting thing I found with all road models was that after pouring 120 milliliters of water down each road model, about 10 milliliters of water stayed on the model road. This was the case for each and every time I ran the experiment. At the end of all my experiments, it was clear that multiple layers of medium used together was best at filtering debris and absorbing water. And that if this well-designed bioswale was implemented implemented into a road, it would have the same results. You could see that the best single medium results I achieved was with soil, when it absorbed 22% of the water. When I added small rocks to stabilize the soil, it increased the water absorption by 3% to 25%. When I created a bioswale with layers of medium, water absorption increased to almost 80%. This was an improvement of almost 300%. With well-designed bioswales added to the road model, I decreased the amount of water that ended up in the gutters from 53 milliliters to 9 milliliters. This decrease of 83% means that the water would have ended up in the gutter remained absorbed in the bioswale. It's pretty clear that my hypothesis was proven to be correct. A well-designed and implemented bioswale is effective at capturing water and filtering out pollutants. If I was to do this again, I would use a less fine sand to see if I could keep it from filtering through the perforation. I would also plant plants in the bioswale itself to see if their roots held together different mediums enough to affect water absorption. Plants would be a very important addition to real-world bioswales because flowering plants could be added. Not only would you have a decrease in flooding and pollutants, you would also increase the habitat of local pollinators. This concludes my presentation. I hope you enjoyed it and that you have a great day.